Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise and we're going to try to find horizontal or vertical tangency to the polar curve. In this case, it's r equals 1 minus sine theta. And this is a very classical question from Calc 1, right? To check if there's any horizontal or tangent lines to the given equation. But that time we worked on mostly of the form like y equals f of x or x equals g of y, or even implicit version of the function. But this time we're in the polar coordinates, so we have to redefine what means to be dy over dx. So for that purpose, please refer back to this table here. So that sort of like replaces dy over dx with the version that involves only theta. So if, in fact, dy over dx is the ratio of two theta-related expressions here. So I'm going to use this within the video. And also, to give you some heads up, and these are the graphs of the cardioid where you have, at certain locations, you have horizontal and vertical tangent lines, as you see. So, and we're going to sort of like pinpoint those points and for which theta or thetas we do have horizontal or vertical tangent lines. Again, I don't want to give you more details. Have your calculator ready, put it in the polar form, and buckle up. Let's get started. All right, let's look at this problem. We have r equals 1 minus sine theta provided to us, and we're supposed to find horizontal and vertical tangent lines to the curve. Now I want to take you back to the formulation here that tells us what the slope of a polar equation looks like in terms of r and theta. As you see that here on the left-hand side, we have dy over dx. And to calculate that, by the way, we use the same trick that we used in the parametric equation. So you're just dividing both top and the bottom by d of that variable here, that is theta. So we're dividing by d theta. Okay, and you get this ratio here, and f theta is the right-hand side of r provided to us in the question statement. Okay, so one quick fact from calculus is that if you want to have a horizontal tangent line, okay, then dy over dx is supposed to be 0, okay? So the slope, in other words, is supposed to be 0. And in this context, to make the slope exactly equal to 0, you need to make the top of the fraction in the right-hand side to be 0. In other words, you want to have f theta cosine theta plus f prime theta sine theta to be exactly equal to 0. So that is going to provide you a trig equation to solve for theta. And vertical tangent lines happens when the slope is undefined. Okay, so dy over dx is undefined. And in this context here, whenever the bottom is 0, and that means that this slope is not defined. So in other words, I'm going to look for theta satisfying the bottom part of the fraction to be exactly equal to 0. Okay, so this is sort of like a quick observation from the slope formula in the polar form. Okay, so why don't we go ahead and try to solve these two equations for the given form, which is r equals 1 minus sine theta. So I'm going to solve like two equations here. Let me just split here. One is for the horizontal tangent line, and the other one is for the vertical tangent line. Let me just write down the equations. So in one case, f of theta cosine theta plus f prime theta sine theta equals 0. Okay. In the other case, you have minus f theta sine theta plus f prime theta cosine theta equals 0. At this moment, I can tell you that this is f theta. And we can also write here what f prime is, and that is negative cosine theta. So right now, all I'm going to do is to substitute f prime in both equations, and f prime and f, in fact. and try to solve these trig equations. Let's see what's going on here. Let me just rewrite those equations. So 1 minus sine theta cosine theta plus minus cosine theta sine theta equals 0. That's the first equation. And the second equation, minus 1 minus sine theta plus minus cosine theta equals 0. Okay. Let's simplify this further. So cosine theta here is a common factor. Why don't we pull that out? So you have 1 minus sine theta minus sine theta equals 0. Okay? All right, let's simplify this one. So it's minus sine theta plus sine squared theta minus cosine squared theta equals 0. And at this moment, I want to write everything in terms of sine, so I'm going to replace cosine squared by 1 minus sine squared from the Pythagorean theorem. Okay, so now I'm going to rearrange everything. So I have 2 sine squared theta plus, let's see, sine theta. I'm going to double check everything. Minus 1 equals 0. Okay, minus 1 plus. Oh, this is minus, I'm sorry. This is minus. Oh, wait. Okay, good. So the coefficient of sine theta should be minus 1, okay? All right, it's right here. So what do we have? On the left, I have cosine theta 1 minus 2 sine theta equals 0. I'm sorry that I'm doing all these like simultaneously, but I think it works so you can actually see both cases side by side. Okay, so in the first case, I'm going to solve this equation. In the second case, I'm going to solve this equation. Okay, I'm going to move on to my next slide, and I'll make a cleaner slide so we can actually have a lot of space to work on. And here we go. Let's just try to solve this. I have 2 solutions coming out of this. One is cosine theta equals 0, and the other one is 1 minus 2 sine theta equals 0. Okay? And this one is equivalent to solve sine theta equals 1/2. Okay? And for this one, we're going to sort of like try to factor this out by using a quadratic formula, because this is like a quadratic equation for sine, right? So if I have like, let's say x equals sine theta transformation, it's like 2x squared minus x minus 1 essentially, okay? And go ahead and factor this out, and you will see that this is written as 2 sine theta plus 1 and sine theta, I think minus 1. Okay, this is the right factorization of that. And now I have 2 solutions here. One is 2 sine theta plus 1 equals 0, and then sine theta minus 1 equals 0. And the first one is further simplified. Sine theta equals negative 1/2. And the last one is just simply sine theta equals 1. Okay? So at this moment, we're trying to solve like 4 trig equations. I'm going to solve them one by one. All right, so watch out. First, I'm solving cosine theta equals 0. Okay? And go ahead and check the unit circle. Cosine theta becomes 0 when you are on pi over 2. Okay, so cosine pi over 2 is 0. And as well, 3 pi over 2 is another option to go with. Okay? So at the 2 poles on the unit circle, cosine is 0. So theta equals pi over 2 and 3 pi over 2 coming out of that. And I'm only looking, by the way, for thetas in between 0 and 2 pi at this moment, okay? Because this is one full period for the given function, okay? Because the given function is 1 minus sine theta, and one full period happens in between 0 and 2 pi, because sine is a 2 pi periodic function. That's why I'm only considering thetas in between 0 and 2 pi. Okay, so all 4 quadrants only, okay? And this one is sine theta equals 1/2. And at this moment, you can use, by the way, your calculator. You can look at arc sine 1/2, but that's going to spit out only one value. So to be able to solve these equations correctly, you should be able to use your calculator, plus you should also use the unit circle in the meantime. So you should have to use your calculator in a very educated way. Let's put it that way. Okay. Go ahead and if you want, punch in arc sine 1/2 just to see what you are going to be given. There's going to be one value for sure that's going to come out of your calculator. That's pi over 6. Another value is something that you have to find by yourself, and you're going to use the fact that sine is also positive in the second quadrant, and there's an equivalent angle that has the sine 1/2, and that is 5 pi over 6. Okay. And now we're solving sine theta equals negative 1/2. Okay. Sine is negative in the third and the fourth quadrant, and if you punch in arc sine negative 1/2, you're going to get one of those values. I think 11 pi over 6 is the one coming out of your calculator. In fact, that doesn't even come out this way. It's going to come out as minus pi over 6. You're going to be very careful, okay? Minus pi over 6 is not in none of those. Is in the fourth quadrant, but it's not the terminal angle, okay? So you should go find something in between 0 and 2 pi, okay? So the corresponding equivalent form for that is going to be essentially 11 pi over 6, okay? 11 pi over 6, that's the version in the fourth quadrant. And then there's also a similar angle in the third quadrant whose sine is negative 1/2, that's 7 pi over 6, okay? So two more coming out of this. And then we are looking at finally sine theta equals 1. Sine theta is 1 only at pi over 2. And here we go, theta equals pi over 2. Okay? So I have 4 locations where I have horizontal tangent lines, and I have 3 locations I have vertical tangent lines. And go ahead and plot 1 minus sine theta. And I did for you, and I want to verify those vertical tangent lines and horizontal tangent lines I came up with. Here we go. Here we go. I have a horizontal tangent line right here at this point, and right at this point. Okay. As you see, let's check if these are the right points. Let me see. Horizontal tangent lines happen 3 pi over 2. Pi over 6, and at pi over 2 it's a little bit problematic because even though we got this out of our analysis, look what's going on here. I want to point I was supposed to point that out earlier, but you have 2 different you have theta equals pi over 2. That makes both the top and the bottom of that fraction that we started with 0, okay? Because theta equals pi over 2 solves both equations. So you're going to have 0 over 0. That's not the vertical tangent form. So we should eliminate theta equals pi over 2 right away. And you can see that from the graph. In fact, if I zoom in here, as you see, the tangent line here is not defined, okay? Right? Because on the left and right, the tangent line is completely different. So it's not defined. So the only tangent lines happen at this point, and this point, and this point, and these are the corresponding theta values we came up with. Okay. How about the vertical ones? Vertical ones happen at these locations here. So let me just use a different color here. Okay. Or here, same deal, right? And did we have anything else to eliminate? Well, we already eliminated pi over 2. We already eliminated pi over 2, and we have only 2 locations where we have vertical tangent lines, and that is correct, and that's lining up with the graph of the function here. Okay. Wow, that was a long question, but we got it sorted out. I'm sorry for my remark that I had to say it at the end. Pi over 2 is a bad angle because that makes the top and the bottom of the slope form a 0 in the meantime. So we sort of eliminate that right away. All right. Well, thanks for watching. If you have any questions or comments or suggestions, please send those to my way. I'll see you in another video. Bye.